Good morning, everybody. Welcome to a fun-filled morning of Chem 1105 with your host, me, Dr. White. All right, today we're going to be doing a review, starting a review for the whole semester. It will help you on the final. Remember, next Monday at 9 a.m., I will send out an email with the password for the final exam, your version. Just like all semester, I'll have two versions of the final, and you'll take one of them. And I've already posted on Blackboard. You should have received the email about the particulars of the final exam. It's comprehensive, and also what point areas from each test. The best way to study for the final is use your hourly exams as practice problems. Will I put the same problems on the final as on the test? No. However, if you look at my practice problems, aren't they similar to the problems on the hourly exams? Yes. So you're going to see similar problems? Of course, because that's what we practice and you've learned. Ooh, nothing like blueberry tea in the morning. I've already had my vanilla almond. All right, quick thing. It happens every once in a while, and it happened yesterday. The way they have Zoom set up, the screen share and the stop recording buttons are like right next to each other. And every once in a while, it's only happened yesterday, this whole summer, I clicked on the wrong one, and back part of yesterday was gone. What was lost was later part of the lab discussion and the practice I did with the 3-step, but you can look at that. You can go back and look at other videos to find that. However, with the lab, let me just do a quick review. Yesterday's lab dealt with carbohydrates, excuse me, and what you need to know is when you have a starch, the tincture of iodine, KiNi2 solution will go from brown or reddish brown to blue, actually dark blue, almost black. That tells you have a starch, not a carbohydrate, which is something more. And the reason you mix potassium iodine with iodine is iodine alone is nonpolar, won't go into water. However, Ki, potassium iodide, make Ki3, K plus I3 minus, which is water soluble. And that should help you with lab we did yesterday, our last lab. Now, later today, one more important public service announcement from me, the management. Later today, I'll send out, I'll probably post it as an announcement too. An announcement that you should check Blackboard. I'll be caught up with yesterday's lab by later today and also the extra credit. You should check in Blackboard. If you do not have a score for a lab and you handed it in, let me know. The deadline for that will be, let's make it Friday morning, 8 a.m. If I haven't heard from you about any of the missing labs, your missing labs by 8 a.m. and you haven't uploaded them to me, if you thought you did and do it again, I will put a 0 for each missing lab any person has. A couple of you, that's going to really hurt your grade right now. So make sure you contact me and you get that taken care of. Again, I've already given one amnesty. This is sort of the second reminder, and the last one I'll put out in an email and announcement till Friday, 8 a.m. All right, let's get going. What I will be doing now is a review. It helps students a lot, and let's do it. Thumbs up, people. One more time. Do you see test one review on your screen? Thank you, Ashley. All right. Test one, we started out the semester talking about the 4 branches of chemistry, and you should know they are organic, physical, analytical, and inorganic. By the way, organic is the best, but I'm an organic chemist. Now, I talked about matter. That's anything that occupies space and has mass, and you should know that. Then we went through the chemical symbols. Hold on a second while I will open up my periodic table. And you should, let's find out. On your screen, you should see the periodic table we've used all semester that will be provided to you for the final exam. And you should know the 37 elements. If I ask you what's the chemical symbol for nitrogen, you should know it's N by now. If I ask you give the chemical symbol for krypton, that's Kr. And if I ask you what's the chemical symbol for the element potassium, and you should know that's K. And you should be able to do that for the 37 elements I asked you to learn. I didn't ask you to learn the whole periodic table, but I did ask you to learn that. All right, let's continue on. And next, I talked about the 3 states of matter, and you should know this. And the 3 states of matter, remember, we did our semi-virtual. If we were in a classroom now, I'd say, class, what's the first state of matter? And you'd all say solid. And then the next state of matter, and you'd say liquid. And the last state, gas. And you should know a solid has definite shape, definite volume. A liquid has indefinite shape, but definite volume. And finally, a gas has both indefinite shape, indefinite volume. Again, the 3 states of matter: solid, liquid, gas. And you should know solid, definite shape, definite volume, liquid, indefinite shape, definite volume, and gas, indefinite shape, indefinite volume. Next, I talked about types of matter, and we have pure substances and mixtures. And for pure substances, we talk about the elements are pure and compounds. Example, if you had water or sodium chloride, salt, that would be a pure substance, assuming it is pure. And for this class, let's assume. Then I talked about mixtures. That's where you have 2 substances or more mixed together, and neither or any of the substances mixed together loses its chemical identity. When we talk about mixtures, there's 2 types: homogeneous and heterogeneous. A homogeneous mixture, which we learned later on, we also call a solution, is the same throughout. An example of that would be your pop. That's a homogeneous mixture. Remember, Dr. White's from Chicagoland area all my life, except when I went to Michigan State for grad school. And the stuff in a bottle that's non-alcoholic carbonated or can, we call pop, not soda. All right, another homogeneous would be if you took sugar and dissolved it into water or salt, that would be homogeneous. And also your gasoline should be homogeneous. It's going to mess up your car big time. Now, heterogeneous, it's not the same throughout. An example of that would be if you've ever seen oil vinaigrette dressing, there's two layers. Or an easier way to think of it is if I had a beaker of water and I dumped in a handful of sand, mixed it up real good with a stirring rod, and then let it set, all the sand would be at the bottom and the rest would be water, and that would be heterogeneous. Now, we talked about physical properties. Notice how I say we, I talked about, you listen. Thank you. Properties of matter. And there's physical and chemical properties. Physical property is something that tells you how something looks. It's physical property, like what color is it, what melting point, what freezing point. A chemical property tells you the ability to change, such as gasoline is flammable, chemical property. Iron will rust, chemical property. Now, we talked about changes in matter, and one change type is a physical change. And that means when matter changes from one state of matter to another, like solid to liquid or liquid to gas, or in the case like dry ice, solid directly to gas. And something that undergoes a physical change retains its chemical identity. Now, chemical change, a substance changes its chemical identity. And as I mentioned, most of all the good organic chemists that I knew, including myself, when we were young, were pyromaniacs. We like to burn things. I did, my friends did, and we had surprisingly, we didn't get in trouble. Shh, I won't say anymore. But anyways, a chemical change is when something changes its chemical composition or properties. An example, when iron does rust, that's a chemical change. When you burn a candle, the wax from the candle is being burnt, and that undergoes a chemical change. Now, I went through and taught you how to the different temperature scales, Fahrenheit, Celsius, and Kelvin. That's degrees Fahrenheit, degrees Celsius, and Kelvin. And here are the formulas. And you should know how to use these. Remember, 1.8 and 32 in the first formula are exact numbers. Same thing in the second formula, and in the third one, 273. Now, what I didn't open up, and I better do that right now. All right, thumbs up, people. Help me out. Do you see important information? Final exam. Who's the fastest? Thank you. All right, you should go before Monday. You should look, and this is in the lecture folder of Blackboard, the file secretly named important information final exam. These are things, this will be part of the final exam. As I said at the beginning of the semester, a year and a half, more than that, a couple of years ago, I decided, should I teach test memory and chemistry or just chemistry? And I decided, excuse me, test is chemistry. Therefore, all the things on these pages of important information, final exam, you don't have to memorize, but you do know how to, have to know how to use it. And like I just went through, here are the three formulas for temperature change or going from one scale to another conversion. Now, we talked about scientific notation. I will not put any specific problems on the test for scientific notation, other than you should know how to use it. And I've taught you how to do that. But one thing I shall mention is when you take the final exam and you're using scientific notation, make sure the number that's multiplied times 10 to the n is never less than 1 or 10 or greater, because it's going to be wrong, and I'll mark it wrong because that's not how you write a number in scientific notation. Now, next I talk to you about significant figures. I will not have on the final, like I had in test number 1, specific question, how many significant figures in this number? Because now you've been using it all semester, but I will have under your name, please use proper significant figures for all calculated answers. And if you get it wrong, I take off a point. And 5 or 6 of those wrong, that could hurt your grade. So make sure you review significant figures. I'll do it right now. All non-zero numbers are significant. Leading zeros are never significant. Confined zeros are significant. Trailing zeros and no decimal point are never significant. And trailing zeros with a decimal point are significant. Again, I will not ask on a test, on the final exam, how many significant figures are in this number, but you should know how to do that. Next, I talked to you about rounding off. If you have something that's 7 significant figures and you want it to be 3 or 4, I taught you how to round off. And I'm not going to go through this because we've done enough this semester. Review it on your own. But I will talk about the operational rules. And those are that multiplication and division, you get the same number of significant figures in your answer as the number that you multiply or divide by that has the fewest significant figures. Again, I will repeat it. When you do multiplication division, you get the same number of significant figures in your answer as the number you're multiplying or dividing that has the fewest significant figures. And if it doesn't, then you round off, which is if you're using your calculator, you will. Also, I taught you addition. It wasn't until chapter test 2 material that you actually used it, and you get the same number of significant figures to the right or past the decimal point when you're adding. We didn't do any subtraction to speak of this semester. When you're adding, as the number you're adding that has the fewest significant figures to the right of the decimal. And we went through this, and we'll do that later today when we do molecular weight. Next, I just started discussing the periodic table, and you should know the key groups: alkali metal, alkaline earth metals, halogens, and noble gases. And let's go to our periodic table. And yep, you should all see it now. If not, someone say something in chat. But anyways, the first column, but not including hydrogen, are the alkali metals. The second column on the left on the periodic table, which I only asked you to learn magnesium and calcium, are the alkaline earth metals. We go all the way over to the right. The second to last column, fluorine, chlorine, bromine, and iodine, FCl, Bri, are the halogens. And finally, the last column, all the way over on the right, are the noble gases: helium, neon, argon, krypton, xenon. And those are the not halogen, are the noble gases. They used to be called inert gases till about, wow, 10, 15 years ago already. Very inventive chemists found a way to make some of those react, and you couldn't call them inert. Now that they might react, you got to go to really, really severe reaction conditions to do that, but they still could react, so they're no longer considered inert. And that's why we had the name change. And I actually have down here, what's a metal? Like silver. Next, we finally started getting into some chemistry. I started talking about the atom. And you should know the atom is the smallest part of an element that has all the properties of an element. And we talked about Dalton's atomic theory, which I will not ask on the final. That's my secret. I won't put Dalton's theory on the final question. But he was the one who came up with that elements are made of atoms. Now, switch was and still is on as full as I can turn it or click on the subatomic particles. And you should know, and if we were in a class, we'd be doing class participation now. The first subatomic particle is the electron. The next one, protons. And the final one, neutrons. You should know electrons have a negative charge, protons have a positive charge, and neutrons have no charge. And let's all do it together. You don't have to turn on your mic, but come on, help Dr. White out, and let's do it. First subatomic particle. Yep, I heard it. Electrons. Second one. You're right, protons. And the third one, yep, neutrons. And you should know electrons negative charge, protons positive charge, neutrons no charge. You should also know the nucleus of the atom. And what is that? That's the center of the atom that contains protons and neutrons. And who elucidated the nucleus? Rutherford and his gold foil experiments. Elucidate means figured out. It's a fancy word. Sometimes I use fancy words. But anyways, you should definitely know nucleus, center of the atom, contains only protons and neutrons. Now, when we talk about atoms, there's the atomic number. And you should know the atomic number equals the number of protons. And because all atoms of the elements have a net zero charge, that means it also equals the number of electrons. And if we go to our periodic table, if you look in the upper right-hand corner, that's the atomic number. And I would ask you, how many electrons and protons does carbon have? Your turn. Time's up. And the answer is 6. Next, I would ask you, how many electrons and protons does calcium have? Your turn. Time's up. And calcium Ca is right over here, 20. Now let's do one more. Let's make it real expensive one. How many electrons and protons does gold have? Time's up. Chemical symbol gold, AU. And It's 79. Time for some irrelevant information. How many of you have ever seen the early James Bond movies? Sean Connery was the best James Bond, no doubt about it in my mind, the best. And one of his best movies was Goldfinger. If you haven't seen Goldfinger, you're missing a great movie. And the villain of that movie, last name Goldfinger, first name Auric, which AU, that's came from, I believe, Latin, but I may be wrong, gold. And that's why it has the symbol AU. Aren't you glad you took my class and you learned all this interesting information? All right, so remember, the atomic number tells you how many electrons, how many protons. Next, I talked about where are the electrons. They're in shells and subshells, and the shells have names 1, 2, 3, 4, and the subshells have 1, 2, 3, 4. It tells you if you know shell 1 has 1, subshell 2, 2, 3, 3, 4, 4. The subshells are S, P, D, and F, but for my class, we only did S and P. S has 2 max electrons, you can put it in at P6. Listen close. As a special COVID-19 gift to you, things are getting bad out there with the Delta variant. I will not put a question on the final dealing with electron shells. No electron shells on the final. That's my special gift to you. No electron shells on the final. Now, if someone's not here, well, I'll have to study it unless they see this video. But remember, special private gift just to you. It'll be no electron shells on the final exam. But you should know valence electrons. And you should know what are valence electrons. Those are the outermost electrons of an element. And how do you find the valence electrons? You look at the top of the periodic table. And the number there, Roman or Arabic number, numeric, tells you how many valence electrons. The maximum number of valence electrons is 8. And let's have some fun and do some valence electron practice time. All right, how many valence electrons does, oh wait, I haven't done it all day. So I better get my money's worth out of this. I'm not sure how many points I do this, but 2 or 3, something in that range. And why don't you try this out? Your turn. How many valence electrons, and I'll post the periodic table in a second, does carbon, bromine, and sodium have? Again, carbon, bromine, and sodium. And here's a periodic table. Again, carbon, bromine, sodium. Your turn. All right, let's do this. How many valence electrons does carbon have? Carbon, chemical symbol C. You look on top, and his number in red, or the Roman numeral IV, is 4. So carbon has 4 valence electrons. Next was bromine, Br. Look on top, and you see the Roman numeral VII, which is also the numeric number 7. So bromine has 7 valence electrons. And finally, if we look at sodium, Na, look at the top, and it's 1. And that's how you do valence electrons. And that's everything that was covered on test number 1. Are there any questions for any of the material covered on test 1? Ooh, stop. Can I go back to what, Jada? Oh, and I'll put down the answers here. Got it? You're welcome. All right, let's move on to test number 2 material. And test number 2, we started out with the Lewis structure. And the Lewis structure for elements, and this is important for elements, shows valence electrons. And the element symbol, you have 1 dot per side, and then you double up. And if I were to ask you, draw the Lewis structure, for, well, let's do sodium. Remember, this is valence electrons. And then let's do more than 1. And let's do B, bromine. Why? Because we already figured out this has 1 valence electron. This has 7 valence electrons. I guess I could put VE or VA, whatever. Your turn. Draw the Lewis structures for sodium and bromine. The first thing you have to do is look up how many valence electrons, but we've already done that. Sodium 1, bromine 7. All right, let's do this. How do you do sodium? Write down the chemical symbol, Na, and on any side, put 1 dot. I put it there. There are 3 other sides you could do it. Now, bromine has 7. That's the awfulest looking B. That's better. And it has 7 valence electrons. So you put 1 on each side before doubling up. And for bromine, 3 sides have 2 dots and 1 side has 1. Doesn't matter which, but that's how you would do it. Now, next, we got into some real exciting stuff, really. And that's chemical bonds. And there are 2 types. Ionic bond, you should know the definition. Transfer 1 or more electrons from one atom or group of atoms to another atom or group of atoms. Ionic bond. Covalent bond, sharing of 1 or more pairs of electrons between 2 atoms or atoms. So you should know ionic bond, transfer 1 or more electrons from one atom or group of atoms to another atom or group of atoms. And the covalent bond is the sharing of 1 or more pairs of electrons between atoms. Now, chemical bonds are formed because of the octet rule. And the octet rule, which I'll never ask on a test, but you should be familiar because it affects how you do things, is in compound formation, atoms of elements lose, gain, or share electrons to get 8 valence electrons, the same as the nearest noble gas. And because of that, let's talk about ions. Positive ions are formed when an element loses 1 or more electrons. Negative ions are formed when an element gains 1 or more electrons. Now, the important thing is elements lose, gain electrons to have the same number of electrons as the nearest noble gas. Elements never lose protons. And remember, all molecules have a net zero charge. So question is, what ion does the following elements form? I have here calcium and sulfur. I'm going to let you try this, but for that, you will need a periodic table. So remember, what ions does calcium and sulfur form? Your turn. Ooh, I haven't done this in a long time. When you're done, give me a thumbs up. And hang in for a second, there's something I need to do. That's not what I need to do. There it is. All right, let's do this. Question is, what ion does calcium and sulfur form? Calcium is right here, Ca, has atomic number 20. What is the closest noble gas numerically? You have two choices, argon at 18, krypton at 36, and hopefully I'll pick argon. So what does that mean? For calcium, it's got 18 protons, 18 electrons. It wants, oh, wait, I made a boo-boo. 20 protons, 20 electrons, and it wants to go to calcium. Still, you're not going to lose protons, but we'll go to the same number of electrons as argon. And now we'll have an octet, the outer valence electrons. And each proton is a +1. Each electron is a -1. Add them together, you get a +2, and you show that by either this or this. Now for sulfur, sulfur has 16 protons, 16 electrons. It wants to go to sulfur, it will still have the same number of protons, but the closest noble gas is again argon with 18 electrons, each proton plus one, each electron minus one. Add it up, you get a -2. So you show the ion by either of those two. And that's how you do ions. And you should practice that. Now, next I showed, how are we doing time? We're doing good time-wise. How to determine writing the chemical or empirical formula for ionic compounds. And you do that by using the concept all molecules have a net zero charge. And as an example, I have for calcium and chlorine. Let's do some others instead. Here's one for you. Write the formula for the molecule. Write the empirical formula for the molecule with the following ions. Your turn. You got 15 seconds. Go. Time's up. How do you do this? Magnesium has a +2 and iodine has a -1. And this has to equal 0. It doesn't. You can't change the charge, but you can change how many. And now if I do that, it will be equal to 0. What does that mean? 1 magnesium and 2 iodine. And that's how you do it. And guess what? Oh, we went a whole minute over. It's time for our break. Come back at 9:56. I'm going to go stretch. I'll see you in 5 minutes. Oh no, I'm running late, sort of. But anyways, I was looking out my window. My neighbors across the street are getting the concrete poured in, or they just about finished for a new driveway. It's always fun to watch them pour and uh, put in new concrete, at least for me. All right, let's get back to work. Ooh, I haven't done this. Let's get back to work. It's official now. Now, I asked, write the formula, empirical formula for a molecule with the following ions. Let's do one more. And this is one for you to try. As calcium +2. I just mangled up. Let's try this again. And bicarbonate -1. Your turn. All right, time's up. This is a +2 cation. This is a -1 anion. When you add them up, they have to add up to 0. They don't. You can't change the charge, but I can say if I have two of these, 2 times -1 be -2 +2, and that does equal 0. How do you write that? 1 calcium. When there's no number, it's 1. Now, for a polyatomic ion, when you have more than 1, you put it in a bracket. And how many do I need? 2. So I'll do subscript 2, and that's how you do it. Again, for a polyatomic ion with more than 1 of them in a molecule, you put them in a bracket, and to the right subscript, you put a number. Oh, let's do one more. Keep on wanting to write, and I keep on forgetting. Most of you can't read cursive. Oh, is that sad? And why don't you try this last one? Write the empirical formula for the molecule with sodium plus cation and sulfate SO4 -2 anion. All right, let's do this. This is a +1 charge for sodium. The sulfate is a -2 charge. It has to add up to 0. Does it? No. I can't change the charge, but I can say if I have 2 of these, that'd be +2 plus 1 of these -2. That adds up to 0. So how do we write that? This tells me I have 2 sodium. I have one sulfate, and that's the molecule that you find in those little packets where it says don't eat in electronics, optical goods, and other things they're trying to keep dry. In fact, I don't know if you like it, but I like dried seaweed. You know, the strips that Costco's got really good stuff. And in each one of the ones you buy from Costco, they have individual containers self-wrapped. You buy 10 of them in a big package. And each one at the bottom, they have a little packet of sodium sulfate. That's to keep the seaweed dry. And oh, it's really good if you like seaweed like that. It's called nori, the right name, but somebody correct me if I'm wrong. All right, let's get back to chemistry. Next, I talked about covalent molecules, and we have covalent molecules. We talk about covalent chemical bonds. There are three types, and you should know the three types are single bond, double bond, triple bond. And you should know single bond has one pair of electrons, double bond has two pair, and triple bond has three pair electrons. Single bond, one pair, double bond, two pair, triple bond, three pairs. And I taught you how to draw the Lewis structure for molecules with covalent bonds. And there you want to make sure each element has an octet of its own and shared electrons, has an octet of its own and shared electrons. The one exception is hydrogen. Hydrogen's octet is 2. And I'll do these. How do you do that? As soon as you see Lewis, you should know valence electrons. Hydrogen, 1 valence electron. Oxygen, 6 valence electrons. How do you do that? Well, 1 hydrogen, 1 oxygen, 1 hydrogen. Hydrogen has 6 valence electrons. Oxygen has 6. Hydrogen has 1. Same thing here. And this one says to that, oh, let's share. And it does. And this one says to that, let's share. And it does. And there you go. Now, guess I'm going to let you try one. Why don't you try B? How many valence electrons does nitrogen have? Look at the top and you'll find it has 5 valence electrons. Why don't you try that? All right, give me a thumbs up when you're done. You people still do that? Sorry I missed you, Jade, on your question. And the answer is at the top of the periodic table. Let me open it up real quick. If you look at the numbers in red, those are the valence electrons. Oxygen 6, nitrogen 5, hydrogen 1. And that's how you find them. All right, let's do nitrogen. Since this is, I don't want to do my thumbs up, I assume everybody's done. You really shouldn't assume that, but I will. Nitrogen, 5 valence electrons. There are 2 of them. Remember, 1 on each side. Now, for molecules, the 2 on each side maximum doesn't apply anymore. For molecules and Lewis structures, the 2 dots maximum on each side doesn't apply anymore. Now, this nitrogen says to that nitrogen, I have 1, 2, 3 unpaired electrons. And you have 1, 2, 3 unpaired electrons. Let's share them all. And the non-bonding electrons come along for the ride. And I have 3 pairs, first, second, and third. And what kind of bond is between nitrogen atoms and nitrogen gas? And the answer is, you're right, triple bond, because there's 3 pairs of electrons being shared. Now, I'm going to do sodium cyanide. Remember, alkali metals never form covalent bonds. What ion does sodium form? +1. Carbon, again, sodium has 1 valence electron, not again, but, and carbon has 4 valence electrons, and nitrogen has 5 valence electrons. Well, carbon has 4, nitrogen has 5, and carbon says, I've got some unpaired electrons. You have 1, 2, 3 pair unpaired electrons. Let's share. It's still a cation, and they do. If you notice right here, nitrogen has 2, 4, 6, 8. But we look at carbon, has 6 shared, but only 1. That's 7. Should have 8. Well, what happened to the electron from sodium? It went over to carbon, and now it has an extra charge and has sodium cyanide, has both a triple bond and a co-ionic bond between the sodium and the cyanide anion. And that was on test 2 that a lot of you blew it. Make sure you know how to do that. Next, I talked about chemical equations. Chemical equation is a way in graphic form to show a chemical reaction. And at the tail, A and B are the reactants, which I sometimes will mention in class, but not on a test, starting materials. At the head of the arrow is C, which is the product. Reactants, base of the arrow, head of the arrow, products. Now, because of the conservation of mass law or law of conservation of mass, on each side of the arrow, you have to have the same number and same type of atoms of each element. You never create or destroy matter in a chemical reaction. And we call that balancing a chemical reaction. And remember, you can only change the coefficients. You can't change the number or type of number of atoms in a molecule. Now, my advice to you then and now again is leave hydrogen and oxygen last, and I taught you the even odd trick. On the final exam, there will be three, yes, three balanced chemical equation problems, because that's an important part of understanding chemistry. So let's do one. I'll let you try first, then I'll do it. And there it is. Balance the following chemical equation. Your turn. I should have some background music to play while you're doing a problem like this, like game show music. Dun, 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 never mind. And let me check something real quick. We're still recording. I haven't hit that button pause yet. Oh, I'm learning something that yesterday or today I upgrade the new version of Zoom, and they've changed things a little. I'm learning that now. Oh, excuse me. I got a good night's sleep and I'm tired. Give you another 30 seconds. Go. "15 seconds left. All right, let's do this. How do you balance it? Well, you leave oxygen, hydrogen last. So I'll start with aluminum. There's one here, but oh, look, there are two there. So I have two aluminum. How do I get two aluminum on this side? So I get it balanced, put a number 2 in front. Next, hydrogen. Now I'm going to leave that. Oh, sulfur. I have one here, but notice I have one what's in a bracket and outside of the right subscript to the bracket right here. So number 3. So I have 3 sulfur. How do I get 3 sulfur here? Put a 3 there. Next, I'll do hydrogen. I have 3 times 2, 6 hydrogen. Oh, I only have 2 here, but I need 6 hydrogen. Well, 2 goes into 6 3 times. And all that's left is oxygen. How many oxygen on this side? 3 times 4. Oh, that's 12. How many here? 4 times 3. That's 12. And now I'll check. 2 aluminum, 2 aluminum. 3 sulfur, 3 sulfur. 6 hydrogen, 6 hydrogen, and 12 oxygen, 12 oxygen. We did it. It's balanced. You should know how to balance a chemical equation. Now, next we got into my favorite area of general chemistry, the mole. And you should know what is a mole, which, if you remember on test 2, I asked that question. And a mole is the chemist's counting unit. You can also say 1 mole of an element equals Avogadro's number, 6.02 times 10 to the 23rd atoms. 1 mole of a compound equals Avogadro's number. Uh-oh, the 2 fell off, 6.02 times 10 to the 23rd molecules. 1 mole of an element equals the atomic weight of that element, and 1 mole of a compound equals the molecular weight of that compound. And the molecular weight is in grams is the sum of all atomic weights. And if we look at important information, final exam, oh, we found the 2 there. I feel relieved. Excuse me. And what I just mentioned, I have right here. That way you don't have to memorize it. It's there for you. Now, one of the things I didn't do in review of test 1, if you go through the practice problems, chapter 1, you'll see what are the 3 states of matter. You should know how to do that. Name a pure substance, name a mixture, name is vinegar, oil vinaigrette, homogeneous or heterogeneous. And then here's some of the, give the name of the element with the following symbol. I have questions about, is this a physical or chemical property? Is it a physical or chemical change? And I would highly recommend here, you should know how to do this one. So I'm going to get rid of it. I have here from test 1, how many valence electrons does each of the elements have? We've already done that, so I can get rid of that. All right, let's blow this up so you can read this. How many molecules are in 6.22 moles of HCl, hydrochloric acid. And here's where I started teaching you your good buddy, your good friend, unit analysis. I love it. And unit analysis has been my good buddy, my good friend for a long time. So here's where I started teaching you how to do word problems. What do? Find out what are you being asked to solve for, including the units. And I use a question mark to indicate that moles of molecules of HCl. What are you given? 6.22 moles of HCl. Whatever you're given, you start with, and you multiply times some ratio, and the answer, what units do you want? Molecules of HCl. Unit analysis tells us whatever you're trying to get to goes on top of that ratio, molecules of HCl. Whatever I'm trying to get rid of, the moles of HCl, go underneath. And where do I find a relationship between molecules of HCl and moles of HCl? If you look at it, 1 mole of a compound equals Avogadro's number, 6.02 times 10 to the 23rd molecules of that compound. And 1 mole HCl equals Avogadro's number. 8 moles of HCl divided by moles of HCl cancel out. Notice this is 3 significant. 1 is an exact number, plays no role in how many significant figures your number has, your answer has, and 6.02 is 3 significant, so my answer is 3 significant figures. Let's do a little different here. And here's one for you to try. Am I nice today or not? I like to share and let you have fun too. How many moles of sodium bromide, NaBr, are 7.75 times 10 to the 45th molecules of NaBr, sodium bromide? And an important information, and 1 mole of a compound equals 6.02 times 10 to the 23rd molecules of that compound. Your turn. And when you're done, give me a thumbs up. Oh, wait, I forgot. This is, I don't want to raise my thumb up emoji class. Oh, maybe I might be wrong. Again, when you're done, give me a thumbs up. Oh, wicked. Just found out in the old version, you could only pin one person. Now I can pin you too. All right, let's do this. What are we being asked to find? How many moles of sodium bromide? What are we given? 7.75 times 10 to the 45th molecules of sodium bromide. And what does that mean? Well, it's time to use your good buddy. I better do it today because I may not have, tomorrow's the last day we have lecture. Use your good buddy, your good friend, unit analysis. Love that whistle. Seriously, this is what we have to start with. I have one ratio. What do I want my units to be? Right here. Moles of sodium bromide. And unit analysis teaches us that whatever you're trying to get to goes on top of the ratio. Whatever I'm trying to get rid of goes underneath. And now I'll write that in. And where do I get these numbers? From way on top here, which is also important information. 1 mole of a molecule equals Avogadro's number of those molecules. And I'll put that in. Now, remember, anything divided by itself equals the number 1, cancels out. So molecules of NBr divided by molecules of NBr, those units cancel out. I'm left with moles of NBr, sodium bromide, and I'm on the right track. So now I'll pick up my calculator. First, I got to turn it on, clear it, make sure it's in scientific notation. Now put in 7.75, second key, double E, 45 divided by 6.02, blue double key, or whatever color it is, 23, hit enter. Whoa! And my calculator gives me the following number. There's more, but this is 3 significant figures. This is 3 significant figures. This is an exact number. Exact numbers play no role in determining the significant figures of the answer, but in multiplication division, you get the same number of significant figures as the number with the lowest significant figures that you multiply or divide by. 3, 3. Your turn. Round this off to 3 significant figures if you haven't done so already. Time's up. Keep the 1, keep the 2, keep the 8. Use the 7 to round off. Is that 4 or less, or 5 or higher? Hopefully I'll pick 5 or higher. Drop this, this, this. Number in front, increase by 1. And that'd be 1.29 times 10 to the 22nd. You should know how to do this. And hence, you should know how to do that type of mole problem. It was on test number 2. And I have a number of examples here you should know how to do. Next thing I asked you to know how to do is the molecular weight. And the molecular weight of a compound is the sum of all atomic weights. So how do you do that? All right, let's do some. What's the molecular weight of water? Well, how do you do that? Water has 2 hydrogens, 1 oxygen. Now you have to find the atomic weight of hydrogen and the atomic weight of oxygen. How do I do that? I go to my friendly neighborhood periodic table. All right, if we look at oxygen right here, thumbs up, people. Do you see the periodic table on your screen? Thank you, Ashley. If we look for oxygen, the number underneath the chemical symbol in this periodic table is 15.999. That's the atomic weight. Same thing for nitrogen, 14.00, and so on. However, on the final exam, like test 2, 3, and 4, I have under your name, please use proper significant figures for all atomic weights. And oxygen to 3 significant figures rounds off to 16.0. Hydrogen to 3 significant figures, 1.01. Again, the number underneath the chemical symbol in our periodic table is the atomic weight, and molecular weights are the sum of all atomic weights. So hydrogen is 1.01, oxygen 16.0, multiply it, 2.02, 16.0, add it up, because the molecular weight is the sum of all atomic weights, and we get this. Now, when you're doing addition, you get the same number of significant figures to the right of the decimal point as the number that has the fewest. For hydrogen, 2.02 has 2 to the right. For oxygen, 0.01. Which is the lower number? And hopefully I'll pick 0.1. So I keep the 0 past it, use this to round off. It's 4 or less. So the correct answer for A would be, would be 18.0. Let's do sulfuric acid, H2SO4, 2 hydrogen, 1 sulfur, 4 oxygen. Hydrogen, I've already done, looked up, I should say. Sulfur, we'll do in a second. Oxygen, we have 16.0. This would be 2.02. That would be 64.0, if I did my math correctly. If not, somebody correct me. But let's look up what is the atomic weight to 3 significant figures for sulfur? Well, it says 32.066, but keep the 3, keep the 2, keep the 0. You round off with the 8. Is that 4 or less or 5 or higher? It is 5 or higher. So I will drop that and the 0 increased by 1. So to 3 significant figures, sulfur's atomic weight is 32.1. Now, when you do the math and check I did it right, but I think I did, get 98.12, but you have the same number of significant figures to the right of the decimal point. This has 2, this has 1, this has 1. What's the lowest number? Hopefully I'll pick 1. So how do you round this off to 1 past the decimal? Keep the 1, use this to round off. Is that 4 or less? Yes, I'm going to drop it. And the right answer would be this. And that's how you do atomic weights. If I look at the clock, let's take a 5-minute break. Everybody come back at 10:47 and we'll continue on. 5-minute break time, 5. Well, I just thought of something. I'll do it next semester. I was going to have a special break time, but you'll remember. I'm back in 5. Let's get going. All right. We've just gone through molecular weight. And remember, 1 mole of a compound equals its molecular weight of that compound. And if we look at, let's do number 7. Thumbs up, people. Can you see number 7? How many moles are 45.33 grams of sodium chloride on your screen? Thank you, those of you who just gave me your thumbs up. All right, how do you do this? Well, what are you trying to find? How many moles of sodium chloride? Salt. Don't forget, please pass the NaCl. And so, how many moles of sodium chloride? What are we given? 45.33 grams of sodium chloride. And therefore, this is what we're given. We have grams of sodium chloride. We want to go to moles of sodium chloride. And now we'll use our good buddy, our good friend, unit analysis. Yeah, I'll do it one more time. And whatever we're trying to get to goes on top of the ratio. Whatever we're trying to get rid of goes underneath the ratio. Where do I get a relationship between moles of sodium chloride and grams of sodium chloride? And if you look at important information, final exam, 1 mole of a compound equals the molecular weight of that compound in grams. And the molecular weight, as we just found out, is the sum of all atomic weights. So therefore, what's the molecular weight of sodium chloride? Well, it's the sum of the atomic weights. And over here, molecular weight, MW, is my shorthand for molecular weight. 1 sodium, 1 chlorine, the 3 significant figures, 23.0, 35.5, get 58.5. So for every 1 mole of sodium chloride, there's 58.5 grams of sodium chloride. And notice grams sodium chloride divided by grams of sodium chloride cancel out. Now, on the final exam, like test number 2, 3, 4, underneath your name will say, please use proper significant figures for all significant figures or for all calculations. And also it will say, please use 3 significant figures for all atomic weights. 45.33, 4 significant figures, 1 exact number, 58.5, 3 significant figures. Therefore, your answer should have 3 significant figures. Oh, let's do one on your own. So the question is, how many grams H2SO4 sulfuric acid are 5.111 moles of sulfuric acid? And in case you need it, right up here is the molecular weight of sulfuric acid, which we just calculated. And why don't you try that out? Remember, in important information, it will say and your turn. And we're still recording. After that happens, I always go back and check to make sure we're still recording. Oh, generation gap time. None of you will understand this, but if you had your webcam on now, which none of you have, but if you did, I could say, smile, you're on candid camera. None of you know what that means at all. Look on Google, try Google, smile, you're on candid camera. For my generation, that means a lot. All right, I'll give you another 25 seconds. Go. My clock's running slow today, so I'll give you a little extra time. I'll actually give you less. All right, let's do this. So how do you do this? You look and say, what am I being asked to find? And that's grams of H2SO4, sulfuric acid. What am I given? How did that 4 move down there? It's mysterious Wednesday. What am I given? 5.111 moles of H2SO4. So this is the only number I have to start with. What am I trying to get to? Grams of H2SO4, sulfuric acid. And now it's time to use my good buddy, my good friend, unit analysis. Oh, my lungs still hurt, which is a good thing. Grams of H2SO4 go on top. Whatever I'm trying to get rid of, go underneath this ratio. Let me write those in. On the final exam, show your work. 1, it will help you get the right answer. And 2, if you make a mistake, I can give you partial credit. Show your work. Now, where do I get a relationship between grams and moles of a compound? Right here, which will also be an important information. 1 mole of a compound equals the molecular weight of that compound. What's the molecular weight of sulfuric acid? Well, we just calculated that. So for every 1 mole, you have 98.1 grams. For every 1 mole, you have the molecular weight of sulfuric acid in grams. Notice moles divided by moles cancel out because anything divided by itself equals the number 1, meaning it's gone. And I'm left with the right units. Now, first of all, I'm going to pick up my calculator. I have 5.111 times 98.1 equals, and my calculator gives me this following number. And would that be the correct number? Time's up? No, because this is 4 significant figures. This is 3 significant figures. And this is exact number, no roll. So when you multiply and divide, your answer has the same number of significant figures as the number with the lowest significant figures. This is 4, 3. Hopefully I'll pick 3 as lowest. Keep the 5, keep the 0, keep the 1. Use the 3 to round off. It's 4 or less. I drop everything. So the correct answer is 5.01 times 10 squared grams of sulfuric acid. And that's how you do it. And you should know how to do this. And you should know how to do this. Don't tell anybody I'm giving away stuff. All right, let's look at something important that I don't have down here, but we did talk about. And that is for a balanced chemical equation. Let's get one on the whiteboard. Didn't know they named this after me. No, they didn't. And here I have a balanced chemical equation. Let me make sure you can see my whiteboard, and you should. Thumbs up, people. I haven't asked this in a while. Do you see the balanced chemical equation on there? Thank you. And remember, the coefficients, the number in front, when there's no number, it's really the number 1, give you molar ratios. That's the coefficients give you molar ratios. That means 2 moles of hydrogen react with 1 mole of oxygen to make 2 moles of water. Again, 2 moles of hydrogen react with 1 mole of oxygen to make 2 moles of water. So this won't be on a problem alone, but you should know. All right, let's look at the following. This is part of another problem, which we will get to today. But the question is, how many moles of water are made when you react 5.612 moles of oxygen with an excess of hydrogen? Whenever you see the word excess, that means you can forget what it's related to. So what are we being asked to find? What are we given? And therefore, I'm going to use my good buddy, my good friend, unit analysis. This is all we have to start with. No, we also have this chemical equation, balanced chemical equation. This is what I'm starting with, moles of oxygen. I want to go to moles of water. Dare I do it again? I will. Use your good buddy, your good friend, unit analysis. Hopefully you're not getting whistle overloader. But anyways, whatever I'm trying to get to goes on top of this ratio. Whatever I'm trying to get rid of goes underneath. And therefore, I have moles of water. I want to get rid of moles of O2, oxygen. Where do I get these numbers? From the Valence chemical equation up here. For every 1 mole of oxygen, when there's no number here, it's the number 1. For every 1 mole of oxygen, I make 2 moles of water. For every 1 mole of oxygen, I make 2 moles of water. And these are exact numbers. So they play no role in the number of significant figures. This is the only number. It has 4 significant figures. My answer should have 4 significant figures. And now, what do? Pick up my calculator. Hold on. But you can see, clear it. I have 5.62. Hold on. Let me try it again. 5.621. Hold on. Why aren't we clearing? There we go. Times 2. And my calculator gives me the following number. This is 4 exact numbers. Round this off to 4, keep the 1, keep the 1, keep 2, keep the 4. Use this number to round off, drop it because it's 4 or less. And this is the answer you get. Oh, you should have some fun too. And here's one for you to try. How many moles chlorine are needed to make 4.66 moles of sodium chloride? Your turn. While you're doing that, I need a refill of water. I see a question. Jada, do you mean to this right here? All right. There we go. While you're doing that, I'm getting a refill. This is almost empty. All right, thumbs up, people. If you're done, give me a thumbs up. I see one person done. Oh, if we had been in a class, ooh, then there was two. If we had been in a classroom, my water bottle was empty. I'd say I'll be back in a second, and outside there's drinking fountains. Well, normal times. I think they shut off all the drinking fountains at COD. I don't know. I haven't been there in over a year and a half because of the pandemic. So, but if at normal times, whatever that means. All right, let's do this. What are we being asked to find? Moles, chlorine, Cl2. What are we given? 4.66 moles sodium chloride. The only thing we have to work with is this. So I will. And if I had a ratio, what units do I want my answer to be? Moles of chlorine. And now I'll use my good buddy, my good friend. I won't use the siren whistle again, so I don't want you to have siren whistle overload or poisoning. Whatever I'm trying to get to goes on top the units. Whatever I'm trying to get rid of goes underneath. Where do I get those numbers? From my balanced chemical equation. The coefficients, the number in front, give me the molar ratio. By the way, let me put the things in here. And where do I get this ratio? Moles of chlorine to moles of sodium chloride from the balanced chemical equation. And if there's no number in front, the number is 1, like in this. And that means 1 mole of chlorine makes 2 moles of sodium chloride. 1 mole of chlorine makes 2 moles of sodium chloride. So for every 1 mole of chlorine, I make 2 sodium chloride. And these are exact numbers. And for this problem, I don't even need my calculator. Well, I hope not. And the answer you would get is 2.33 moles NaCl, 3 significant figures, exact numbers, 3 significant figures. And that's how you do it. Remember, the coefficients of a balanced chemical equation give you molar ratios. Now, next thing I taught you was doing mass calculations for reactions. That's going from grams to grams. How many grams of something is needed to make so many grams of a product? Or another way, how many grams of a reactant do I need to make so many grams of a product? Or how many grams sodium, or how many grams of a product will I make if I start with so many grams of a reactant? Got that finally out. And there you need 3 steps. because you can't go from grams of one compound directly to grams of a second compound. And those 3 steps are: step 1, convert the mass of whatever you have to moles. We just did that. Step 2, convert the moles of what you just converted to moles, in this case A, to moles of B. We're using the balanced chemical equation. We just did that. And finally, take the moles of B and convert it to grams of B. We just did that earlier today too. Know how to do this. It's my second gift of the day. Boy, am I being nice to you. And it's not even Christmas or Hanukkah. Maybe it's your birthday, but, and for those who don't celebrate those religions, tell me a holiday you have in yours where you give gifts. And I'll mention that tomorrow. But anyways, I try not to discriminate against any religion whatsoever. But anyways, hold on. Now I'll get your attention. Know how to do this. Let's look at what is this. Nope. I've already done this problem set. Make sure you look at Chapter 5, Part 1, Mole Practice Problems, Part 2. Make sure you look at Chapter 5, Practice Problems, Mole Practice Part 2. Now, the first couple of problems, like number 1, we've already done. How do you put this all together? You look at number 4. Thumbs up, people. Do you see the following reaction? C3H8 plus 5O2O gives you 3CO2. Thank you, Alexa. All right. How do you do this? The question is, how many grams C3H8 propane are needed to make 24.6 grams of CO2? You can't. What are you being asked to find? Grams of C3H8. What are you given? Grams of CO2, carbon dioxide. You cannot go from grams of one compound to grams of another in one step. You can't. You need 3 steps. Now you can combine them in one math formula, but I like to separate them. And where do you get the 3 steps? You look at important information. I have mass calculations. Remember, mass means grams. And therefore, you convert mass of A to moles of A. Whatever you're given in grams, you convert to moles. Second step, now whatever you just converted to moles of that compound, you convert to moles of what you're trying to solve. In this case, moles of B. And the last step, because you're trying to find grams of B, you convert moles of B to grams of B. So let's look how that's done. And before I continue on, remember, know how to do this. Get the hint? Get the big hint? Know how to do this. On test 2, most of you, how do you like that? That's from the cartoons. You choked on it. You messed up. Some of you did real good, but a lot of you had problems. So follow along. First step, whatever you have in grams of A, in this case, that's C3H8, you go to moles of that compound. So here's what I have, 24.6 grams of CO2. I want to get the moles of CO2. Use unit analysis. Whatever you're trying to get to goes on top of the ratio. Whatever I'm trying to get rid of goes underneath. Where do I find a relationship between moles of a compound and grams of a compound? From important information, final exam, 1 mole of a compound. Boy, this is thirsty work. Equals the molecular weight of that compound in grams. And the molecular weight of that compound is the sum of all atomic weights. So 1 mole of a compound equals the molecular weight of that compound in grams. What's the molecular weight of CO2? 1 carbon, 2 oxygens. Do the math, add it up, and you get 44.0 grams. Now, this is a multi-step problem. You can round it off at each step like I do, or wait till the end. I will calculate for the final exam both answers, and if they're different, both will be correct. But here I'm a each step person, so 3, 3, 1 is an exact number, 3 significant figures. Now, excuse me, the second step is whatever you just figured. Oh, I got the hiccups. This is a dangerous problem. Hold on, let me hold my breath. There, that stopped it. Moles of A, whatever you just found, in this case C3H8, to moles of the answer molecule. And what's the answer? We're trying to get the grams of C3H8, but in step 2, we just calculated moles of CO2. We want to go to moles of C3H8 propane. So here we have moles of CO2. We just calculated that number. And we want to go to moles of C3H8 propane. Whatever we're trying to get to goes on top of the ratio. Whatever we're trying to get rid of goes underneath the ratio. Where do we get those numbers? From your balanced chemical equation. If you look up here, when there's no number, the coefficient is 1. 1 mole of C3H8 makes how many moles of CO2? 3 moles. So for every 1 mole of C3H8, you make 3 moles of CO2, carbon dioxide. These are exact numbers, 3 significant figures. My answer is 3 significant figures. Are we done? No, we want to get to grams of propane, C3H8, but we have moles of propane. So now we have to do the final and third step. Whatever we have in moles, we convert to grams. And how do you do that? Let's not leave this first. Remember, 1 mole of a compound equals its molecular weight in grams, and the molecular weight of that compound is the sum of all atomic weights. In that case, I'm trying to go from moles of C3H8 to grams of C3H8. And how do you do that? Well, you have to find out what is the molecular weight of C3H8 propane. By the way, propane is the white stuff, organic molecule into white tanks for your barbecue, and you burn it, and you learn that reaction. 3 carbons, 8 hydrogens. Each carbon has an atomic weight of 12.0. Each hydrogen, 1.01. Do the math. That's 36.0, 8.08. Notice, add them up, you get 44.08. 36.0 has one significant figure to the right of the decimal. 8.08 has two significant, which is a smaller number. You're right, one. So round that off to one, past one significant figure past decimal, keep the 0, use the 8 to round off. Is that 5 or more? Yes. Drop it, and number in front is increased by 1. So it's 44.1. So for every 1 mole of propane, C3H8, there's 44.8 grams of propane. Moles of propane divided by moles of propane cancel out. This is 3. This is 3, exact number. Our answer is 3. And if you notice on there, I have 8.20 grams of propane or 8.22. If you round it off at the end, that's what you get. I'd highly recommend that you look at those other problems of the 3-step problem from chapter 5, part 1, mole problems, part 2. Look at it. It will help you. Now, I'm going to put out a poll because I can't remember if I did something or not. Nope, that's not what I want. Now, I'm going to use our "you done" poll, but I'm going to ask you, did I talk about capsaicin in here yet? Yes, I did, or no, I didn't. And it looks like I didn't. I didn't think I did. And therefore, it's time for a cliffhanger. Coming attractions tomorrow. Tomorrow's class, our last class of the semester. Oh, the summer went boom. But anyways, I'd rather go boom than my lectures go boom. But anyways, egotistic, aren't I? Yeah. No, I know for a fact they do. Tomorrow, coming attraction 1, I will talk about hot peppers. That's organic chemistry. 2, I'll talk about, and I have to admit it, one of the dumbest things I've ever done in my life. And 3, I'll teach you how I use my knowledge of organic chemistry to undo quickly the dumbest thing I've ever done in my life. One of the dumbest things. I've done more than one, but this has to almost take the cake. I'll teach that tomorrow. Now, public service, big announcement from Dr. White. Practice for the final. The other day, what was it, yesterday? Today's Wednesday, tomorrow, yesterday was Tuesday. See how smart I am? Oh, that was a bad joke. I won't use that again. But anyways, I showed you how to calculate how many points you need on the final exam to get the grade you needed or want based on your test score total and the formula I gave you. Don't forget that was assumed you handed in, did all the labs. All right, now remember, a number of you are in a good spot. Thank you. Makes me happy that people are doing well. However, don't think, oh, I don't have to get that many points on the final. I'm not going to study hard for it. Don't. I've seen too many students do that, in classes I taught, and they get a grade 1, sometimes 2 times lower than what they should have gotten if they studied for the final. Study for the final like you need every point. Study for the final like you need every point. Hold on one sec. All right. Remember, study like you need every single point. And that way, if you didn't need them, you'll still get the grade you wanted. If you did need them, you'll get the grade you wanted. All right. Another important public service announcement has nothing to do with Chem 111 or 1105, wrong school. Anyways, Chem 1105, if you haven't gotten your vaccine shot for COVID-19, get it. You're gambling with your life. If you've been following the news, people your age are getting this and they're dying. For some reason, this is really hitting people real hard, especially normally younger people. Notice I'm not. That's why I got mine. Actually, it took me a couple of weeks to get an appointment. I was getting really nervous. Come on, I want to get it. And now you don't have any problem. There's so many places you can just walk right in and get your first shot, come back, I think it's 2 weeks, get your second shot. No, they don't use 2 needles. Get it. People, do you really want to gamble your life? One of the saddest things I heard the other day, it was yesterday, I read it, was from someone who died. The last thing he texted his wife was, I should have gotten the vaccine. That was a big mistake. Then he passed away. How sad, how unnecessary. It's safe, get it. Really, thank you, Rain. In Cook County, they'll send out a nurse to your home or they'll come right to your door. That's not what I wanted. That's what I wanted. Anyways, if you live in Cook County, I know DuPage is pretty straightforward, and so is Kane. They're everywhere. You can go on the internet. You people know how to use Google and find a place and get it. All right, with that, all right, Rain just said, I think you can all read your chat. All right, with that, I'm going to end a little early because I don't want to start something now that I'll rush through. Tomorrow, I'll go through test number 3, and I'll repeat some of the important stuff from test number 4. And coming attraction tomorrow, I will I'll talk about A, hot peppers, or yes, organic chemistry. B, one of the dumbest things I've done concerning hot peppers. And C, how I use my knowledge, and I'm going to pass it along to you, of organic chemistry to get out of that dumb situation. Actually, it was a real painful situation. Now, one other last thing, don't forget, there's a lab due tomorrow, hand it in. I will be sending out later today an announcement with an email that the deadline for all labs and everything concerning labs and anything else, well, the extra credit deadline is long gone, is Friday morning, 8 a.m. After that, if you haven't talked to me about your situation, ask me to resolve it, I will be putting in zeros in my grade book and Blackboard. So check Blackboard and make sure for each of the labs you've handed in, I've graded it. And with that, I'm going to let you out a couple minutes early, a whole 6 minutes early, the whole semester. I've never done that. With that, gang gesund. Goodbye. And don't forget, I have my office hour tonight from 5 to 6 on Zoom if you need any help. Gehen gesund. Goodbye. And don't forget, wear your mask out there. It's dangerous with the Delta variant. Bye now.